Okay, so hi guys, we are going to take a quiz on tomorrow. So a few of these questions we've already done in class together. If you need more practice, then please go back over the problems that are in your notebook. So the problems that I'm going to answer for you will be the ones we didn't do in class. The standard that we're looking at and will be quizzed on tomorrow is to identify and to describe relationships among inscribed angles, radii, chords, tangents, and secants. What you're gonna go over is the different lines and segments of a circle and the different lines and segments outside a circle. These are our key vocabulary words. I'll talk about them as we go through. You already have these in your notes, so this is like a review. This one we did in class. So this is one of the ones we didn't do in class. It says find a perimeter. So perimeter means to, if you see the word rim in there, add up all the sides. If you look at the type of lines we have here, our line segments, this is a piece of a tangent. And I know it's a piece of a tangent because right here is the point of tangency. This is my point of tangency. So I have this piece going this way and this piece going this way. So the rule says that if I have two tangents coming out of a point of tangency on a circle, then the two sides, when they intersect, the two sides are the same length. So 7.3 here, and this is 7.3 here. So if I go down to this one, then the same rule apply. These are tangents. So if this is 13, so is this side 13. And we need to find this piece here. We need to find these two pieces. But in order to find this side, I need to go over here and find this side. So what I'm going to do is take 25.8 and minus it from 13. So I'm going to grab the calculator. 25.8 minus 13, and that's 12.8. So this yellow piece is 12.8, and if this is 12.8, then so is the other side. Now I found these different pieces, but I haven't answered the question yet. It said find a perimeter. So you're going to add all of those pieces together and scratch this one out so you don't add it in there twice. Add it in there. Oh yeah. So we're going to do 13 times 2, because I have two 13s, plus 7.3 times 2 plus 12.8 times 2, and grab your calculator. Let's see what that is. So 13 times 2 plus 7.3 times 2 plus 12.8 times 2 equals, so we get 66.2, and you can put whatever units you want. And perimeter is a linear, the units are linear with perimeter. All right, so that is number 2. Let's go along. So here's another one. So here, number 4, you have to notice what type of lines you have. I have a secant here, and it's a secant because it intercepts the circle twice. And this over here on the other side is also a secant because it intersects the circle twice. And I'm dealing with line segments, so the formula that I'm going to use is outside times whole should equal the outside times whole. So on the yellow line, I'm going to put in red the outside, which is 8. And I'm going to put in purple the whole for the yellow line, which is this. So I'm going to say parentheses 8 plus x. You need to make sure you remember these formulas. So you need to know what type of line you're dealing with and the formula that goes with it. In blue, I'm going to put the outside of the green line, which is 7 And then I'm going to put in black the whole for the green line, which is 7 plus x plus 3. Okay, so now here is to do the math. So you put your line down the middle, and remember, constants are on the left. Constants are on the right. Variables go on the left. So here we need to distribute. So we get 64 plus 8x equals, and then we distribute on the right side, 49 plus 7x plus 21. Now I'm going to tell you, you could have went ahead and combined like terms inside of the parentheses, and yeah, I'm going to go back and do that. Well, I'm not. You can combine like terms to follow please excuse my dear Aunt Sally first, but either way, you're going to get the same answer. Rather you combine like terms first, then distribute, or if you distribute like I just did. That's just another option in math with solving equations. Now on the right side, I'm going to go ahead and combine my like terms. So 4, that's going to be 70 plus 7x. And now I'm going to get my variables on the left and my constants on the right. So I'm going to subtract 64. And then if I cross over this line, I have to change that sign. So this was plus, so that becomes negative. So when it goes to the other side, 70 minus 64 is 6 plus 7x. And then this x is on the wrong side, so I got to move it over to the other side. So I get 1x equals 6. Divide by 1, divide by 1, x equals 6. And it said solve for x, so I don't need to do anything extra to this problem because it asked me to solve for x. You can always make sure I'm right by substituting back in and make sure both sides are equal. Okay, let's keep moving. This we did in class. This one we did in class. Alright, so here's another one. Well, here I had to look at, it says solve for the missing sides. So I need to look at what I'm dealing with. So this is a diameter right here. And here's what's key here. Right here is a tangent. And the point of tangency, I am going to put in black. That point of tangency, so when the point of tangency intersects with the diameter or a radius of a circle, then a right angle is formed. So you get a right angle right here. And you look the other side, that forms a right triangle. So since it forms a right triangle, I am going to use Pythagorean's theorem. Across from the right side is the hypotenuse, that's C. You can call this side A and this side B, or you can switch them up. And because I'm trying to find a piece of the triangle, that's a segment, I can go ahead and use Pythagorean's theorem. A squared plus B squared equals C squared. So you get 12. Anytime you substitute into a formula, please put it in parentheses. Plus D squared equals 20 squared. So I get 144. Plus B squared equals 400. And then subtract 144, subtract 144. And we get B squared equals 400 minus 144. And I'm going to just go ahead and double check my math so you can see how I can use the calculator to help me with squaring those equations. So that's your raised to key, squared. Or if you have a scientific, you can Google how to find your raised to key, or hit me up in class and I'll show you. Okay, so I'm good there. Minus 144, 256. And I don't want to know B squared, I want to know B. So I am going to take the square root of both sides, because the inverse of something squared is to take its square root. So B is equal to, alright, to get the square root on the calculator, you push the second key and push the x squared key. That gives you the square root. And B is 16. So the diameter here is 16. So each little piece is 8. So this is 8. and this is 8. So from the center of the circle to the circumference, that's the radius of 8, and this is a radius up here of 8. If you add them two together, you get 16. So that missing side is 16. Okay, let's keep going. So here's another one. We got it says solve for x. So we need to investigate what are we given. Well, I'm given a line that touches the circumference twice. So it touches here and here. So that is the definition of a chord. So same thing here. I touch the line, the circumference twice, one here and one here. So that's the definition of a chord. So there is a rule that we have for the chord. You take the two pieces and you multiply them. So I'm just going to call this A, this B, this C, and this D. So the rule says to take A, B, multiply them, and that should equal C, D. So this is what I want to do. 12x times 14 equals 16 times 10x plus 1. And you notice I put the pieces that go together. The pieces on the purple line, I multiplied them, and the pieces on the yellow line, I multiplied them. This is one of those formulas that you need to make sure you memorize so you know what kind of lines or line segments you're dealing with, and you have to know the corresponding formula for that. So I'm going to do 12 times 14 here. So I'm drawing my my line, and I'm going to solve my equation. Variables on the left side, constants on the right side, and if I cross over the line, I need to change the sign. So here we get 8 equals 16. Well, 8x equals 16. Divide by 8. Divide by 8. X is equal to 2. Alright, so we're done with that one. Okay, here's another one. This one is the same as the one that dealt with perimeter. So I'm going to skip this. You can go and look back at the other one. This one we did in class. This one we did in class. Okay, here's another one. It says the radius of the circle C is 8. Find the measure of arc AB. This symbol up here means arc. It's a little loop. Alright, so I am going to highlight what they're asking me to find the measure of this. So that means I need to find this arc right here. And it gave me some information that the radius is 8. So from the center to the circumference of the circle is 8. Center to the circumference of the circle is 8. If you notice that this is a right triangle and it's asking me to find this arc. So if I find this piece, if I find what this angle in here equals, then I know that the arc is going to be exactly the same measurement, because the rules for a central angle is the central angle equals the same thing as the intersecting arc. So here, what I'm going to do, I notice that that's a right triangle. So I'm going to draw this right triangle. This is 6. This is 8. And when I find this angle here, then I know this angle, and then I automatically know the other one, and I want to add them together to get what that arc is. Since I'm looking for an angle, I'm going to have to use trig. So I'm going to go to my SOHCAHTOA. If I put my finger here, the side across from the right angle is the hypotenuse, and the side that I'm touching is the adjacent, and the side I can't touch is the opposite. So it looks like I'm going to use cosine, because I know the adjacent and the hypotenuse. So I'm going to say cosine, and I'm going to call my angle x, which I don't know, 6 over 8. I'm going to draw my little trig circle. So we get cosine of x, 6 and 8. I'm trying to find this angle here, so you can put your finger here. So that's telling me x. Just a second. Hold on, the board's freezing. It'll unfreeze in a second. So x is equal to the cosine, and we're going to do inverse. Anytime you're finding an angle, you do trig inverse. And that x is going to be, let's see, when you do your angles in your calculator, check your mode, because we do not want our calculator to be in radian modes. We want the easier mode, which is degrees. So second cos inverse alpha y equals, and I'm going to put 6/8, and that's 41.4, and I'm going to go to the nearest tenth. 41.4 is what that degree is. So this is 41.4, then so is this 41.4, and if I add them together, I get the whole angle to be 8.28, so 82.8. That's what the whole angle is here. And if this is 82.8, then by rule of central angle, the intersecting arc, or the intersected arc, is 82.8. And we're finished with that problem. This one we did in class. Alright, so it says find the measure of arc TS. Well, okay, I am going to highlight what it's asking me to solve for. That is this piece of the arc right here. That's the intersecting intersecting arc. And here, I gotta look at what kind of angle I'm given. So if I'm given an angle, then this is an inscribed angle. So this is what you need to know with the rules, that if this is an inscribed angle, this is y and this is 2y. Now why is this an inscribed angle? Because the vertex of the two rays that make this angle is on the circumference of the circle. So that means if this is y, then this out here is 2y. Well, what I know is that y equals 9x plus 2. And I need to first solve for x in order to get this arc right here. So my 2y should equal double this angle. So I'm going to write this as 2y. They didn't give it to us, but if I double this, then I would know what this arc out here is. So 2y is going to be 2. Wait. For the sake of explanation, I'm going to call this, since I don't know what this is, I am going to, I'm just going to show you. So that should be 2y. So here, then what I would do is to say that the 2y is just equal to whatever the angle is. Let me write it like that so I don't confuse you. Alright, so if I go and I substitute in to get my angle, it would be 2 times 9x plus 2. That's what this angle out here is. So I know this to be 9x plus 2 because I have to double the angle. Now if I go through here and I add these two together, then I know there are 360 degrees in the arc of a circle. 360 degrees. So I'm going to say 2 times x, 9x plus 2 plus 26x plus 4 should equal 360 degrees. So I get 18x plus 4 plus 26x plus 4 equals 360. So I am going to draw my line down the middle and solve the equation. So 18x plus 26x, that would be 4, 2, 3, and that will be 44x. And I'm going to double check myself just to make sure my math is right. 4 plus 4 is 8 equals 360. And that's a skill you guys should do also. Just double check your mental math, make sure it's correct. Sometimes we make mistakes, so you just want to double check, because if you get these numbers wrong, then your answer at the end would be wrong. So make good use of your calculator to check behind yourself. Okay, so we get 44x equals 360 minus 8. 360 minus 8. 352. All right. And then divide by 44. Divide by 44. X equals 8. So we got x to be equal to 8, but that's not what the question asks us to solve for. It asks us to solve for this arc out here. So since we know that this arc is going to be 2 times whatever the angle is, so you do 2 times 9 times 8 plus 2. So you get 2 times 74. And let me double check just to make sure I'm good. 9 times 8 plus 2. All right, 74 times 2 is 148. And so arc TS is equal to 148 degrees. Okay, so let's keep going. Here is another one, number 15. So it's asking me to solve for x, and I am going to go in here and highlight the where x is. The intersecting arc is, I'm going to put it in blue. That's right here. So this is an inscribed angle, and they didn't give me anything to help me out with this, but they gave me enough on the picture. So if I look here, I notice I do have a 56, so I'm going to highlight that, and that's in red. That's an inscribed angle, and since it is an inscribed angle, I know some stuff. So I know that this is y, so the intersecting arc, which is out here, I'm going to put that in purple. This out here is going to be 2 of whatever the angle is, 2y. So then if this is 56 and I take 2 of those, then I get 2 times 56 would give me arc GH. So let me grab the calculator. That's 112. So this arc out here is equal to 112. Well, now if you look in the middle of this circle, there's a diameter. The diameter is a special type of chord that passes through the middle of the circle. And when you split the circle, then the arc out here is called a semicircle. So if I know that from G to H, arc GH is 112, then arc GF would be, well, let me choose a different color. GF would equal 180 minus 112. So I'm going to hit 180 up minus 112, which is 68. Alright, so now I can go and solve for x. This is an inscribed angle, so I'm going to call this y and call this out here 2y. So now I can say, well, y is equal to 7x plus 6, and 68 should equal 2 times y. So I'm going to substitute in what I know y to be, and then I'm going to solve my equation. Constants go on the left, constants go on the right, and variables go on the left. So 68 equals 14x plus 12. So my constant is on the wrong side. I'm going to cross over this line, get it back on the side it belongs on. So here we get 0 is 14x, and then we're going to do 12 minus 68, which is 56 minus 56. And then my 14x is on the wrong side, so I'm going to switch over this line. Negative 14x equals negative 56. Divide by negative 14, divide by negative 14, x equals 4. Alright, so if I go back up, it just says solve for x. So hey, we're finished. So x in this case equals 4. Done. Okay, here's another one. It says find the measure of angle CDB. So I'm going to go highlight what it's asking me to solve for. When you take your quiz tomorrow, use these same strategies. Highlight what it's asking you to solve for. So it wants me to find this piece right here. It's asking me to find an angle. So you have to think, what formula do you know that will help you find angles in a circle when the angle's in the inside of the circle? And that formula is double the angle, and then you're going to say the big arc plus the little arc. Right? So I'm just going to fill in what it told me. So 2 times the angle is 20x minus 2 equals the big arc 138 plus the little arc negative 2 plus 12x. Let me explain this negative and positive. Anytime you see a negative and a positive by each other, erase the positive and put the negative, because that is essentially saying a negative times a positive, which is a negative. Draw the line down the middle. So we get 40x minus 4. We're using distributive property. I'm going to go ahead and combine like terms. 136 plus 12x. Constants go on the right side. So I'm going to plus this constant and get it back on the side it belongs on. So this is 140 plus 12x. And then this constant is on the wrong side. So I'm going to minus it to get it back on the appropriate side. So we get 40 minus 12, which equals 28x. And this equals 140. And then we're going to divide by 28. Divide by 28. So 140 divided by 28. This equals 5. So x equals 5. So we solve for x, but that is not what the question asked us to solve for. It asked us to solve for that angle. So we're going to say the measure of angle CDB equals 20 times 5 minus 2. So you get 100 minus 2, which is going to be 98 degrees. And you finish. Okay, let's keep going. This one we did in class, and this one we did in class. So, I will see you guys in class tomorrow. We will take our quiz, and we are done. Bye.